Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy Mr. Malachi, and I'll be taking you through this video on how do you work out these cast diagram questions. So this is trigonometry, and what the question is asking us, it says given this equation here, and then they give you a range where alpha is an element of real numbers or where alpha lies. And then what the question wants you to find is what are these values of those expressions down there. So what we need to do is I figure out a procedure that we need to follow every single time we solve these type of questions. And this is your procedure. So your procedure reads, the first thing that you need to do is you need to make the trig ratio the subject of the formula, right? And so what that means is we need to take this expression that's given here and we want to see it as just sine alpha is equal to something, some fraction on the right hand side. So let's do that first. So this is quite easy. At this point, we have negative sine alpha is equal to 4. The only thing we need to do is divide by negative 5 there and divide by negative 5 there. And so sine alpha is equal to a negative 4 over 5. As soon as we get that fraction, we need to remind ourselves what is the ratio of sine. Sine is an opposite over hypotenuse. That's what sine is. So looking at this fraction, it tells us that the 4 will be the opposite guy and the 5 will be my hypotenuse. Right? But before I draw it, I need to establish where, in which quadrant is my triangle going to be. So how do I establish that? First thing you need to check is you need to check the sign of this guy. So the fact that it's negative, it's telling me that sine is negative. So where is sine negative? Sine is positive there. It's positive there and it's negative in this quadrant and in that quadrant. All right. So I've ticked the places where sine is negative. Then another thing we need to look at, we look at this range that is given there, and that's going to give us the next clue. So this range tells us that the alpha is between 90 to 270. So it tells me that it's in this quadrant and it's in this quadrant because that's the range from 90 all the way to 270. So that's what that range tells me. Then now that I have established where I have two ticks, that's where my diagram needs to go. So let me draw my diagram in there. Just going to erase this so my diagram can fit quite nicely in there. So this is how my triangle is going to look. Right? And the alpha that we are talking about is this angle all the way around like that. And if I were to label this triangle there, the opposite is given. The opposite will be this guy. It's the negative 4 and my hypotenuse is the positive 5. And maybe you're sitting there wondering, oh, Mr. Malachi, why isn't the negative being going with the 5? Why isn't it a positive 4 and a negative 5? Why isn't this what I'm labeling in my diagram? One thing you need to realize is that we are on the negative side of the y. So definitely this needs to be negative. And another thing you need to establish is that r, the radius of that line, the line there that is labeled as 5, will always be a positive value. So it can never be negative. So in this case, clearly my 4 needs to be the one that's negative and the r needs to be the one that's positive. So now that I've labeled those guys, there's one last thing that is missing there, and is this side right here, the adjacent that I need to solve them. So right now I'm on step, so I've drawn the triangle, I've done step number 2, and I've labeled the triangle. Then now I need to use Pythagoras to find the missing side. So let's do that step right this side. So if you apply some Pythagoras, I'll apply it here. Pythagoras says your r squared, your radius squared, is equal to your x squared plus your y squared. And then the radius we do have, it's the 5. We squared like that. The x is the one we're looking for. We have the y, which is a -4, and we square it like that. And if you do your algebra, you'll get a 25 there, and this will be a 16. And if you take it to the other side, it subtracts. And if you square root on both sides, x is either a positive or a -3. Right? Whenever you square root something, you're either getting a positive or a negative. But then looking at my picture, which side of the x is this side? That is clearly the negative side of my Cartesian plane. That's where my negative x values are. So it will make sense to make this a -3. So here at the end, you just need to establish that x is actually a -3. Looking at our diagram, right? Then now we've completed our diagram. Now we can start answering these questions here. So let's answer those questions. The first one we asked is, what is 5 cos alpha minus 3 tan alpha? So what is cos? Cos is always adjacent over hypotenuse. And what is tan? Tan is always opposite over the adjacent. So what I need to substitute is those ratios in place of the trig ratio. So a over h, the a is the -3 over the +5 minus the 3. The o over a is a -4 divided by a -3. And at this point, you could just plug that into your calculator. And if you do so, the value that you should be getting is, so you should be getting a -7 as your final answer there. And there we go. We've answered question A, or question number 1. Let's do number 2 there. So if I scroll a little bit. So number 2 says, what is 4 over sine alpha minus 3 over cos alpha? So again, I need to check my diagram. It's a 4 divided by the ratio of sine, which is O over H, minus the 3 divided by the ratio of cos, which is A over H. And if I just scroll, actually I have it here. There's my O over H, which is a 4 divided by a -4 over 5 minus a 3. My A over H, I used it here. It's a -3 over 5. I'm just copying it from there, but you could just look at your diagram there. And what I should be getting here is a -5. And what I should be getting in this case is a +5. So this ends up being a 0. Let me just double check that using my calculator. And so yes, 0 is the correct answer for that guy. So let's try another question of these. What will be nice to see is the contrast. So this question, we were given obviously the equation, right? But we were given a range in this case. Let's look at one where we're not given a range and we're given something else. Let's look at that question. Alrighty, let's try this next question. So in this question, we're given that √2 tan theta plus 1 is equal to 0. And we're given that cos theta is greater than 0. And then we're asked to solve these expressions down there. So again, what we're going to do first, we're going to go to our procedure. please copy this down. You're going to need it at some point. The first one says, make the trig ratio the subject of the formula. So let's do that first. So we're given this trig ratio up here, and we're going to take that and we're going to make it the subject of the formula. So we're going to have a root 2 tan theta plus 1 is equal to 0. We're going to first take the 1 to the other side. And so we have a negative 1. And then we're going to divide on both sides by root 2. And at this point, tan theta is equal to a negative 1 over root 2, right? And right next to that, I'm going to write what my tan theta is. It's always opposite over adjacent. Why am I writing that? So I know exactly where to label the opposite and where to label the adjacent, and which is the opposite and which one is the adjacent. So in this case, the 1 will be the opposite, the root 2 will be the adjacent. Then step number 2 says, now we need to draw our triangle on the cast diagram. So there's my triangle, there's my cast diagram, A, S, T, and C. Another thing, we have our degrees there. Always going anti-clockwise, right? And so let's establish where our triangle needs to be. So our 10 is clearly negative. So the fact that he's negative here tells me that it needs to be in a quadrant where 10 is negative. So where is 10 negative? 10 is negative there at S, and he's negative there at C. So that is the first thing. Then the second thing I need to look at, in the previous question we looked at a range, but in this case we look at this guy. And this guy tells me where is cos positive. So let's establish where is cos positive. In which quadrant? Cos is positive in the first quadrant and in the last quadrant. So where I end up with my 2 ticks, that's where my triangle needs to go. So my triangle looks like that. And if I label that, my opposite is the negative 1. My adjacent is the root 2. And if you're wondering, why isn't the negative 1 going with the root 2? Why isn't the negative with the root 2 and the 1 being positive? Because this side is my negative y and it's the positive x side, right? And then now that I've drawn that, I'm on step number 3. And step number 3 says, use Pythagoras to solve for the missing side. So there's one side that's missing, which is this hypotenuse there. So let's solve for that hypotenuse. The only way to do that is to use Pythagoras. And so r squared is equal to x squared plus y squared. Then I substitute my x, which is the root 2 squared. I substitute my y, which is the negative 1 I squared. I end up getting a 2 plus a 1. And so the r is the root of 3. But why am I not putting plus minus there? Because we know r is always a positive. So it will be a root 3 looking like that as a positive answer. So now that I've solved, I've completed my diagram, then I can start working out those questions that were given. So the first one was, what is the root 3 of sine minus root 2 of cos? So it says root 3 of sine theta minus root 2 of cos theta. So let's substitute. Remember, my sine is O over H. I always just use this first before I substitute. And then my cos is A over H. And then now that I know exactly which numbers to substitute, my O is my negative 1. My H is the root 3. So this will say root 3 negative 1 over root 3. This next one, we have a root 2 at the top, and at the bottom we have this fraction here, and my a is the root 2 and my hypotenuse is the root 3. Sorry, not 3 but root 3. And so if I evaluate this using my calculator, I should get a negative 1 there minus a 1, and this should give me a negative 2. And there we go. So we've calculated the first guy, but we need to do the second guy. I'm just going to move it this side. Number 2. The second question says, what is 1 over cos squared plus 10 squared? 1 over cos squared theta plus 10 squared theta. So let's follow the logic again. 1 over a over h, but this has to be squared, plus o over a, which is also squared. Then if you substitute, you should get, a 1 over, so a over h, I've already used it here. Let me just copy there. Root 2 over root 3, excuse me, squared, plus over, I've not used over. Let me just go up. The opposite is a negative 1. The adjacent is a root 2. And I'm squaring that. You can plug that whole thing in your calculator, and what you should be getting is, alright, and with this one you should be getting a positive 2 as your final answer. And there we go. So just to recap, the procedure kind of stays the same depending on whether you're given a range or whether you're given this trig ratio, whether it's positive or negative. So the procedures are always going to be the same. Number 1, you use your trig ratio and you make the trig ratio the subject. So you take the equation that's given and you make the trig ratio the subject. Number 2, you need to draw your triangle. Firstly, you need to establish where your triangle needs to be, and once you've drawn it, you label the triangle. There's gonna be always one side missing. Then to find that missing side, you use some Pythagoras. And once you found the missing side with Pythagoras, you also need to establish what sign is that missing side. You take it depending on where your diagram is. So in this case, we used Pythagoras, but we were solving for r. R is always positive. But in this question, we use Pythagoras and we were solving for x, and this is the x side. Well, it's the negative side of the x. So that's why I took a negative 3 and not a positive 3. And then once you have your diagram completed, then you can start answering those questions. And remember in those questions, we're not actually solving for theta. We're not solving for the angle. We're just substituting the ratios for each of those. So if you have cos, you need to substitute a over h. If you have sine, you need to substitute o over h. And if you have 10, you need to substitute o over a. And yeah, that's it from my side. I'll post another video on trig reduction, but for trig on the Cartesian plane, this should be enough. Cast diagram. And on that note, thank you. Bye.